I'm going to record what I'm talking about. Okay. Now the formula for ideal gas law is PV equal nRT, and I already have a discussion of this. It's actually tomorrow's discussion, what it would be, but I'm going to kind of put it all together, and I'll have two of them online. So if you don't understand what I'm saying, you go listen to the other one. But in this formula, the N stands for moles. Okay? The N stands for moles. The R is a constant, and it's in your book on page 384. The P, the V, and the T, you all know what it is. It hasn't changed. It's the same stuff it's been. So the only new stuff is the mole and the RT. Now, I'm going to go ahead and go to this screen. And on this screen, I have another derivative, because when we find how many, we know that we have 75 grams and we want moles, and I know that's H2. How do I change grams to moles? Divide by the GMM and put 1 mole up here. Alright, so these two letters, one of them, this capital M, stands for the GMM, molar mass, formula mass. That's other ways to say the GMM, the gram molecular mass. How do I get the GMM? Add stuff up from the periodic table. So I add stuff up from the periodic table. And isn't that where I got this number right here? So I'm dividing by this number. And the little m stands for mass. And it's given, or that's what you're looking for. One or the other. It's either given or you're looking for. Now we're going to decide how to use these two formulas. First of all, I have taken this capital M and I've multiplied both sides by it. So if I multiply this times capital M and this times capital M, it cancels on that side, and look what I have left. PVM equals MRT. Now, in college, you're going to see it like I have it written at the top. But if you go ahead and learn it as a linear equation, it makes your algebra a lot easier. If I'm looking for M, capital M, it makes it a lot easier. So I've written, this is what I call a derivation, derived from the other. And that's a calculus term, where you get the calculus. You derive things. You do integrals, stuff like that, in calculus. All right, so we're working with two formulas. PV equal nRT, and I always write that N as a small letter, but it always looks like a capital N because it's so hard to make an N that, you really tell what it is up here. So I usually just write it like that, but I write it small. When I type it as a small letter. All right, now let's talk about this for a second. When you read your problem, you're looking for three terms: mole, a gram, or a mass. And it might say, what is the molar mass? What is the gram molecular mass? And it may not even say that. But it's going to have a gram in it, or it's going to have a mole. If it has a mole in it, which one of those two equations do you think are to use? The one in red or the one in black? Red. Because what's the N stand for? Mole. So if my problem says mole, I'm going to use that formula. So if the problem says mole, I'm going to use the one that has an N in it. I will never use N and M at the same time. Alright? So if it says mass, or as a unit, what do I do? Use the black one or the red one? You're going to use the black one because it has m's in it, and m's stay mass. Okay? Now, let's read one of these problems and figure out what we're going to do. Your homework, we're going to do number 102. Let's get it number 102. Read. Determine the number of branches. Oh, sorry, that's not the one I'm going to work first. I'm going to work. There it is. I'm going to work number 88 first. Let's go back and catch up to number 88. How many moles? How many moles? Was that one of those key words? Right. So I'm going to put a question mark right here, and when I put a question mark on the end, I ain't going to fool with the end. I either do M's or I do N. I don't do both of them. Okay? So once I put that question mark there, I know immediately there's not going to be any big M or little m. I'm going to mark them out. Are contained in 890.0 milliliters at, and the good thing about these is you only got one temperature, you only got one pressure, and you only got one volume. You don't have to guess if it's going to be volume 1 or volume 2. You only got one. So that makes this a little bit easier because of that. All right, so we're going to 21 degrees C plus 273 equal 294 K. And my pressure is 750. Yeah, I do. What? I've got these two backwards. Okay. I've been so used to having the B's on the top that I just got carried away. All right, so this is going to be 890 milliliters, and this is going to be 750 millimeters Hg. We've been putting volume at the top so long, it just takes me a few minutes to make the conversion back to this. All right, so I have to have everything filled in except the M. Do I have it all filled in? No. So I need to find out that R. So we're all going to look in our book at the R chart, which is at the bottom of page 384. You know, I would have thought y'all had your book out when I said that number was. Waiting on this road.
I gotta get started.
I reckon. Told y'all the other day I'd have to cook.
Yeah.
Okay. All right. Supposed to have it every day. We're on page 384. We're looking at the first two columns. One of them is the unit of R, and one of them is the numerical value of R. So you're actually going to have to get both of those numbers when you look. Now, what's the difference between the unit of R in the first row and the unit of R in the second row? The pressure. So we have three values that we use. We use the first one, which has millimeters of mercury in it, the second one for ATM, and the fourth one for kPa. We don't use that third one, so you can just eliminate that from your thinking. Not mark it out in your book, But you don't look at that when we don't ever use it. So the one we need is which one? The what? 62.4. Now, the way I want you to write this is 62.4, what is it? Been writing it all day, I forgot. All right, liter, mole, liter, milliliter, millimeter Hg, and I want you to draw a long line because we need to visualize that this unit is a fraction. And it's a fraction that works this way. So we're going to put mole K. Now, there are going to be times when we're going to write that unit just like it's written there, and there are going to be times when we have to flip it upside down. Now we're going to talk about when to flip it and when not to flip it. Okay, so we're going to look at that like it's a fraction. It is a fraction. All right, I'm looking for n. Now, like I suggested a while ago, I'm going to circle n. So that means I need to divide both sides by RT. So I have PB divided by RT equals n. Now to work the problem, draw you a nice long division line, and we're going to write down P. That's the first thing we're going to write down. 750.0 millimeters Hg. Then I want to write B. The unit for B, or the number for B, is 890 milliliters. Then I need to put my R. Now listen carefully. The R is going to need a top and a bottom place. I can't put it on this position because I can't write the top part of it that I need to write. Okay? So I'm going to put it in an extra space that I've drawn out here. Now R, where is it? Is it on the top or the bottom of my fraction? When we look here, it's on the bottom. So the number part of the R goes where this R is. The number part is 62.4, and the unit that goes with the 62.4, according to my fraction over there, is liter, millimeter, Hg. Okay? Now the other part of the fraction needs to go above it. I have flipped that whole thing. I have taken it and I have turned it on its head. When y'all see your papers tomorrow, you'll see a lot of that arrow business. Put it in the wooden box so I can reevaluate. Okay? So we're going to flip the entire thing. I put the number part on the bottom, so I put the bottom of that R where? On the top. So mole K. Say it again. When I need to put the R on the bottom, I have to flip all of this. And I want what's on the bottom on my R to be on the top, and vice versa. I want the number on the bottom. The units go with it. These units are very important. A bunch of you lost points on that last test because you didn't put your units. I don't like to write units any more than you do. If I did not think they were important, then I wouldn't bother to write them myself. Okay? I've been teaching for 40 years, so I have a lot of experience. And I'm telling you, I teach you what you need to be able to do. You don't take shortcuts because this is not the end all of everything. Units work problems for you, which I'll show you in a minute. All right? So let's recap. What do I have here? Pressure. What do I have here? Volume. And over here I have my R. Have I taken care of everything? What did I leave out? The T. So it doesn't matter whether I put the T here or here. Doesn't matter. But it's got to be on the bottom. And since I got an open spot here, I'm just going to put it in one of those open spots. Because this unit doesn't have a fraction in it. So I don't need a top and a bottom. I only need a top and a bottom when the unit is a fraction. So let's just put it right here, 294K. Now let's double check. Let's do our canceling first. We're going to cancel our units. What happens to the millimeters of mercury? It cancels. What happens to the K? It cancels. What happens to the milliliter? It doesn't cancel. So I did this on purpose because this is a teaching point. If I forget to change my unit to liter And when I start canceling my units, I can see I have a mistake. If I don't ever cancel my units, then I just keep that mistake, and I have a mistake all the way through, and a big time deduction when I can eliminate that by canceling out some units. Okay, so we're doing it just like we did before. We're going to come over here, 1,000 milliliters, 1 liter equals 0.8900 liters. So I just mark that out and put 0.8900 liters. Now my liters cancel, and what am I left with? What's the only thing not canceled out? Moles. What am I looking for? Moles. Here's my unit, right? I mean, that's what I'm looking for, moles. So now I've got the answer in moles. I've probably got it right. My units have canceled. So I probably have it right. All right, for just a second. If I am told that I have 2 kilograms, and in the problem it says that I've done 10 meters and 5 seconds. And the answer says, and it says, I want to know this answer in kilograms, meters per second squared. Do you know anything about how to work that problem? No, you really don't. But look at the units. What do the units tell you you've got to do? You've got to multiply kilograms times meters, then divide by seconds squared. So I could say 2 kilograms times 10 meters divided by 5 seconds squared. The units are going to come out to be kilograms meters per second squared. And I don't know a thing about how to work this problem, but I know how to make these units work, so in the ACT I can figure it out without knowing anything about it. Some units work problems for you if you just look at the units. The most important thing when you read a problem is to read the units. The number, you go back and pick that up after you've got the units in your head. Because when I see a unit that says ATM, I know that's a unit of pressure. So I don't care what the ATM is, I just need to know it's a pressure. Because the number's not important until I get ready to start working the problem. So look at your units. Units are the most important thing. And you can work out problems that you don't have a clue how to work if you know what unit you're trying to get in the end. All right, so let's back up to here. I'm going to erase all this. And let's work another problem. All right, this one, I'm going to work number 90. Number 90. Calculate the volume. 3 moles. So when I write moles, what do I mark out? M's. So my M's are not important. Will occupy at 24 degrees C plus 273, 297 K, and 762.4 millimeters Hg, and my unit of R is 62.4 liter millimeter Hg mole K. Now, do you think I like to write that form, that unit? No, I don't. But I write it because I need to model how to do this to you. So that means I want you to write it as well. All right, so now we're going to come over to our formula. Are we going to use this formula? No. PV equals nRT. That's a per nerd. That's a per nerd formula. PV per nerd. nRT. All right. So we got our per nerd formula, and we are solving for volume. Circle the volume. What am I going to divide both sides by? P. Now, if you don't understand this magic that I'm doing, you need to ask. I assume that you know how to do this. If you do not, please ask. Don't wait till the day after the test and you failed the test because you didn't know how to do this or why I did it. You have to ask. So my formula is B is equal to NRTT. All right, let's do a nice long line for our division line. My N goes on top. My R, I need a top and a bottom to write it properly. And is it on the top? The R on the top. So I'm going to put the number and the units with the number on the top. So 62.4 liter millimeter Hg mole K. All right, my T is on the top, so 297 K. And my pressure needs to go on the bottom, and it just needs to go in an open spot. Doesn't matter whether I put it in the first open spot or the last open spot, it's in an open spot. So it's closer over here to where I'm standing, so I'm going to put it here. 762.4 millimeters Hg. Now, let's cancel our units. Mole, cancel. K, cancel. Millimeters Hg, cancel. What I got left? A volume. Okay? Want to make sure your units cancel. Now, suppose that I read this and it said collected over water. Collected over water. Got that water word in it. So that would mean that I have to subtract the water vapor pressure from the pressure that was given. Because all of these are the one conditions. You have P1, B1, and P1. That's what those are. Okay, your two conditions are mixed up in this number and this number right here. It's a weird thing that somebody worked out a long time ago, and I'll tell you about it a little bit more than another time. Okay? So if it said water, I still have to subtract the water vapor pressure from the given pressure. That's what we learned in our homework. All right. So, are you done? All right, so now we're going to work one where we use the derivation of this, and that's going to be on 102. Let's look at page one at number 102. Number 102. Determine the number of grams. Remember, we're looking for keyword mole, gram, mass, and we've got grams. So the little m, the unit of the little m is G, and the unit of the big M is G per mole. The little m is a G, and the big M is the GMM. This is the GMM. Add stuff up. So we got determine the number of moles of CO2. I might need to know that. It might help me in that. In a 450.6 milliliter, I know immediately I need what unit? Liter, so 1,000 milliliters, 1 liter is equal to 0.4506 liters. At 1.80 atm. And I've got a minus 50.5 degrees C plus 273 is equal to 222.5 K. Now, looking at page 380, whatever it is, 384, I think, yeah, 384, I need ATM. So that's 0.0821 liter ATM mole K.
Can we mark that here?
Yes, please do. I should have already done it. As soon as I wrote down this gram, as soon as I did something here or here, I need to mark out my end. Because I'm not going to use the end. Okay. All right, so now I'm going to use this formula. My question mark is right there. Oh, I need something here. What am I going to do with this right here? How do you find that? Periodic table and add stuff up. So we would add 12.01 plus 32 for the two oxygens because we're working with CO2. So we get 44.01. That's why we need to know carbon dioxide. That helps us know what our GMM is. Okay with that? Okay? So now I'm solving for this M. What am I going to divide both sides by? RT. So I'm going to have PV capital M divided by RT is equal to little m. Now you will find that in order to keep these straight, if you make both of your letters like this and then your little m is like that, how are you going to know which one's which when you start manipulating that formula? So make a concerted effort to make them different and make them so you can tell the difference and not substitute something in the wrong place. So I use the three humpy things for my little m, because that's a cursive little m, and I use this mountain peaks as my big M. All right, so plug and chug. Do a nice long line. Your pressure is 1.80 atm, and you'll notice that I kind of go across the top, and then I go across the bottom when I put stuff in, so I don't overlook something. My B is 0.4506 liters, right noise, and my capital M is 44.01 grams, and where do I write the mole? On the bottom, because it's per mole. Okay? And if I need the big M on the bottom later, I would flip that. Same way I do the R. All right? And now I need my R. Where's it going to go? Top or bottom? Bottom. 0.0821 liter ATM. Mole K goes on the top. Because I have flipped that fraction. Now the T got to go on the bottom. And I don't want to really draw something else out here. So I'm just going to put it in either this spot or this spot. Doesn't matter which one I put it in. Put it in the one you get to first. 2.5K. Let's cancel our units. ATM. Liter. Liter down here. Mole. K. What am I left with? Gram. What am I looking for? Gram. Okay? Now this is not, I will work one for you that solves for this capital M. I'll probably do that tomorrow. And it's not anything different from what we've done, except your final answer will come out, which will be grams per mole. You'll have grams and moles left over. And if I were to work a problem like that, and I came out with a unit of 40, my answer was 44 grams per mole, can you tell me what chemical that might be? If I find the capital M is 44 grams per mole, you can't necessarily look at the periodic table. What did we just say that this chemical was? CO2. There's not a 44. Sometimes you have to kind of refer back to your experience. And we've done CO2 a bunch of times over the past couple of months, and it's 44 grams per mole. So if I came out with that answer, I could, and the question asked me, what gas is this? It's very okay. We'll talk about that at the next session. Okay. I'm